You just pick 3 points are not collinear.
Yeah.
Name two opposite rays in the diagram. You can say like TX
Yeah.
and TL.
Uh,
We're putting STL and
mhm.
T intersect at point T.
Yeah.
So just take a moment to kind of simmer on that a little bit. So you see how STL
Yeah.
um in plane Z. So if you made a plane here,
Yeah.
oh wait one sec. Um, they'll intersect at line TL. My bad. Because the line would represent the intersection between two planes. Yeah. Then TX and TL, those are opposite rays. And again, just pick two non-collinear points, and that should work. Okay. That's pretty obvious to call those vertical angles. An angle MSN. Yeah, Jason angles, so like LMO.
Wait till I got you on his hand.
What would be the other one?
So it'd be LSO.
LMO.
Oh,
No,
L
Jason angles. LMO,
and
OMN.
yeah.
Because you want to share that vertex.
Uh-huh.
Yeah, you can say angle LSO
Mm-hmm.
and angle LSM.
Uh-huh.
Um, a linear pair just forms a 90-degree angle, which you could probably use the same one again, LSO
Yeah.
and LSM.
Yeah.
Here, GI bisects DGH. So let's see here. Three IGH. So you set those equal to each other. So X equals 10. Okay. For 9, if they're still going to add the 180,
Mm-hmm.
you should get 13 if you use a calculator. And then angle 2 would be 121, I think. Yeah. Okay. For 10, so drawing, you see how drawing helps, right?
Yeah.
Like 5 comma 11, 3 comma 5.
Yeah.
So if you think about it, you're going two right and another 16 down. So you don't have to use formulas. You can just sort of just draw it. And if you use formulas, it's going to be x1 plus x2
Yeah.
over 2 equals your midpoint. Your midpoint, of course, is 5. So 3 plus x sub 2.
Mm-hmm.
Solve for x sub 2, you should get 7. We're here, the 11 plus, oops, sorry, that's midpoint.
Wait. Yeah.
Equals another 11. If you solve it, you should get negative 27. So you could do it that way also.
Yeah.
Take a more formulaic approach.
Mhm.
Yeah. So same thing here. So you're going 2 to get there, so the other direction would be 11. You're going 6 to get down to 5, so you go the other direction 17. So you look at the midpoint, you just want to go on the opposite direction, but equal distance, but opposite direction.
Mhm.
Like here, see, like I went 2 away, so 2 away the other direction. Here I went 16 down, 16 up from the 11 to 5, so I go 16 down. So
Yeah.
you can look like that. And then here, that's just Pythagorean theorem.
Mhm. Yeah.
And then one kind of 14. So if you think about it, you're going like that.
Mhm.
That's the distance of 30 and
Um,
7.
yeah.
So you should get root 949.
Mhm.
And wherever that is, um, we want round to nearest 10th. Yeah, 30.8. Okay. So that's page 1.
Yeah.
Now let's do page 2. Okay, 2 lines. So what 2 lines are parallel to HL?
Uh, F, J, and H, L. Or yeah.
Say again.
Uh,
FJ and
H, L.
no, so no, we're looking at HL. So it's what 2 lines are parallel? So HL is the one that we're looking at.
Yeah.
So you said FJ, that's one of them. What's another that's parallel?
G, J, K, G,
Good,
K.
perfect, good, good, okay. Now, do you know what skew means?
Askew now.
Skew means they don't touch, but are not parallel.
Yeah.
So let's look at FG. FG is right here. Notice that MK won't touch FG, but they're not parallel because they're not going the same direction. But they just don't touch because they're positioned away from each other.
Yeah.
And then LJ could be another one. So you say MK,
Yeah.
LJ. Now, plane parallel to FG, KJ would be this plane. So you can say plane HILM,
Mhm.
HIML, sorry.
Yeah.
Okay. Same side interior angles like 2 and 3.
Mhm.
Alternate exterior.
2, 3, 7, 6.
Yeah, 7 6 could also be same side interior, but for alternate exterior, yikes. You say 8 3. No, 4 8. Sorry, my bad. Because they have to be outside.
And 5, 1.
Corresponding angles, you could say 1 3.
7, 2.
No, the corresponding is like this.
Oh, so one seven eight.
Three,
So
five,
it,
7. Yeah, right. Oh yeah, just set them equal to each other. What's the or possible proves that A is parallel to B? That's just corresponding angles are congruent,
yeah,
and then to actually prove it, just set them equal to each other. Y should be 110.
yeah,
Slope is you take the change in Y or a change in X. So you get negative 2/5, I think. Yep. Slope here is 2. You do 5 minus 3 over 0 minus negative 1. Slope here is negative 1 minus 1 over 6 minus 2.
yeah,
So negative 1/2. So whenever the negative reciprocals each other, that's perpendicular.
mhm,
If they're the same, it's parallel.
yeah.
So remember, you could do a point slope form.
Mhm.
That's the equation line. And then the
Mhm.
line perpendicular just switch the slope from 1/2 to negative 2. Okay, so now we move on to page 3. These will equal each other. So 2x equals 36, x equals 18. And to measure the angle, of course, that's 42. That's going to be 82.
Yeah.
So 3x minus 17 equals 82.
Mm-hmm.
3x equals 99, x equals 33. Here, those add to 180. 8x equals 136. That should be 17, I think. Yeah. And then therefore that's 44.
Mhm.
I think that's 136. Yeah. Oh, cool. Okay. But those are, so I have some practice problems to help you with that. Let me see what I've sent you.
Mhm.
Uh,
I
and
went over for my last test. I went over the practice problems and it helped a lot.
which one? Sorry.
The last test I have, I do not remember which one, but
Hold on.
I remember looking at things. Be like, I watched the video again and like that. Like that. I think that's the only reason I passed the test.
Let's see here. Yeah, I have a practice file I can send your way. It looks like I have not sent it to you yet, so I'll make sure you get that before we enter a call tonight. Okay, so let's go back to what your mom sent. Yeah. There we go. Yep. All right, let's keep moving. So remember we have five, I think, different ways. We have SAS, SSS, um, angle side,
Yeah.
ASA, or HL.
Hmm.
Actually, give me one sec. I just gotta jot down a quick one for you. Just text myself. Okay. So of these five,
Oh,
um, and let me kind of label. So let's start with those six. And let me do this also. And some of these may not have we may not have enough information. That's a possibility too.
yeah.
Um, so start at 27. Do we have enough information to say those triangles are the same?
Yes.
We do.
Yeah.
For what
Well,
reason?
well, uh, nah, because there's like the left one is like completely like different, kind of
Yeah,
like
because see, these two sides are the same, and these two sides, but they have to be the
the
same
same. Yeah.
across, right? So
The
that's
next
that's
one's
not gonna
like
work.
28's right
It's what reason?
because they mirror each other.
But what which of these five?
Or what?
Side angle side, angle side angle, or hypotenuse leg theorem.
Oh,
Well, don't guess. What do we know? We know that one pair of sides are the same, right?
yeah. So
Another pair of
side,
sides are also the same,
yeah.
and they also share this side. So nothing with angles, all just a bunch of sides.
So it's SS side side side.
Good. Then for 29,
Angle angle side.
you have to go in order, angle, side, angle.
No angles.
Angle, side, angle.
Side.
Angle, side, angle. All right. Okay, let's take a look at 30. Now, that's hypotenuse leg theorem because they have right triangles.
Huh?
You have hypotenuse is the same for both. And
Yeah.
like if you redraw them and separate
Yeah.
them out like that,
Yeah.
again, the hypotenuses are the same. That's how you say it, a plural sense.
Yeah.
Hypotenuses. Yeah. And 31, that's nothing. I mean, fine, these angles are the same, but what do you do? It's not enough to, they're similar. We can say that.
Yeah.
Um, Now how about for 32? You have angle, angle, side. Say angle, angle, side, angle, angle, side. That one.
Yes.
Oh, no, sorry. It's that one right here.
Yep.
Right. Yeah. All right.
Oh, can I use that brush real quick? Real
Take your
quick?
time. Go ahead. Go for it. Yeah.
I'm back. Oh, oh, oh,
Just give it a sec. Hold on.
take it down.
Okay, let's do these last three here, and then we'll look at page 4. I'm not sure if we get the pages 5 and 6 today. We could do that tomorrow. Okay, so more on proving these. Let me oh, we're recording. Okay, good. So if you think about it, let's focus here. These are the same. So your triangles kind of look like this. So it's angle, side, angle.
Yeah.
Okay, so it's ASA.
Mm,
And here, they share this side, and of course these angles, these sides are also inside, side, side, side.
mm,
And here, I don't know what else they have in common, so that's nothing. So not, not enough information.
mm.
Okay. That's pretty obvious. That's 65, and that has to be 50.
Mm.
And that's 59, that's 118. So that's 62.
Yeah. Mm,
Um, and then that's 62 right here.
mm,
So these are also 59, 59 because you have similar triangles.
mm.
If all these are the same, it's equilateral.
Yeah.
So then that's 12 for X,
Mm,
and it's 8 for Y. These are the same. Actually, it's equilateral again. So each of these equals 60, so that's 15, and that's 40.
Yeah.
There's a 1 to 2 ratio because that's split in half.
Mm,
So X plus 5, double that equals 3X. So X equals 10.
Man, so 42 wouldn't be
Well,
10.
let's take it.
10's
Yeah,
this.
yeah, so angle Q is the smallest.
Uh,
Angle R is the biggest.
uh,
Then angle P. Then angle Q.
mm,
But for 41, see how these are the same. So 3X.
mm,
So X is 4.5. Yeah, I think that's right. Yeah, and these have to be the same because, you got these congruent triangles here. So yeah. Um, for 43, yeah, it's 46 degrees, clearly. So DF is the biggest side,
mm,
then DE,
mm,
then EF.
mm.
Angle K, is the biggest side. Angle O is smaller because it's obviously angle K is bigger. But
Huh?
they have these the same, but
Yeah.
angle K is opposite a bigger side, so that makes sense.
Hmm?
Yeah, centroid remember is 2/3 of the way. So CW, if that's 15, that's gonna be 5 and 10.
Yeah.
BX is 8, so that's 4.
Hmm?
AZ. So if well if XZ is 3,
Hmm?
that's 6. Yeah, so CX is 10. BY is 12. AZ is 9. And then if that's 6 and 4,
Hmm?
and AY is 7. And it's cut in half because that's the whole point of central. You form all these medians. So AC is 14. The perimeter triangle AXY, this little one here is 17 if you add them up 6, 4, and 7.
Yeah.
Nope. A perpendicular bisector, that's just a median.
Huh?
That's an altitude.
No, that's median. No,
It's
no.
an altitude as well.
Yeah, and then altitude also, I think.
And that's nothing. I don't know what that is.
And you can't do anything.
Yeah, it's not cutting us that half. Angle bisector, you need to show that those angles are the same. We don't see that. You mean you have to cut sides a half.
Hmm?
Perpendicular bisector, you have to be perpendicular and cut something in half, which we don't see. I don't see anywhere else here. So
Yeah.
an altitude is just gonna be perpendicular to one of the sides.
Mhm.
Okay, so we could probably yeah. I mean, actually, this went by pretty fast. Probably just make this shorter call and then
Yeah.
do
Hmm?
more tomorrow. And I think we
That
have
would
more
sound
on
good.
Thursday. So here, LOM
Yeah.
and NPM are the same. LM and NM are the same, and they also
Yeah.
share this angle.
Uh-huh. Mhm.
So when you state it,
Yeah.
yeah. So you say angle NPM given.
Mhm.
You can say LM
Mhm.
given,
Yeah.
and then angle LMO
Yeah. Uh,
to angle NMP. That's going to be vertical angles congruent.
yeah.
And then you can say the triangles are congruent.
Yeah.
That's side angle side. So that's what's happening with that one there.
Uh,
So hopefully that's pretty straightforward for that one.
yeah.
Okay. You're gonna be the right angles. AE bisects BD. Okay, so bisects, I mean those are the same. You want to prove that AB equals ED. Well, we know these are the same also. So this will be our last proof. We can end it for tonight. It's good. We have recorded this whole thing.
Yeah.
And then I could say angle B equals angle D.
Yeah.
And that's because right angles are congruent. We've seen that before in Alex, right? That's been good. We've had exposure to that.
Yeah.
And you don't have to say the given right, all of them right away. Like I could then say AE
Yeah.
bisects
Mhm.
BD. That's given, of course, right? Then what I could say is um give me a sec here. Um just sorry, it's a little perplexed. Yeah, then you can say CB equals CD,
Yeah.
and that's going to be um definition segment bisector, I think.
Yeah.
Then you can say angle BCA
Mhm.
is going to angle DCE,
Yeah.
and that's vertical angles congruent.
Yeah.
And lastly, for the set around of space, but for the six,
Yeah.
you could say the triangles. Oh, then we have to say triangles are congruent. So it's actually 7 steps.
Yeah.
Triangle ABC
Yeah. Mhm.
congruent to triangle EDC,
Yeah.
and that's angle side angle.
Yeah.
And then you say AB equals E, and that's something called CPCTC. I think have we talked about that?
Yeah. Something like
Corresponding parts of congruent triangles are congruent. So yeah.
that. All right.
Yeah, that's a pretty lengthy, perfect. Got 6 o'clock. That's good. Stop the recording.
All
Um,
right.
here.